Hi guys, so today we are going to be talking about inequalities graphically. Alright, so let's say we have a function that looks like this. Okay, so first question, this is kind of review from interpreting graphs. For what x values is f of x equal to 0? So what are we looking for? So we're given an output value and we need to find what input values correspond to the points on the graph with that output value. So fortunately for us, f of x equals 0 is nice because we're given a line. With f of x equals 0, we're pretty lucky because it's pretty easy to see what part of the graph we're looking at, right? Where is f of x equal to 0, or where is y equal to 0 in the coordinate plane? All the points in the coordinate plane that have y equals 0 are along the x-axis. So we just need to look at where does our function run into the x-axis. So looks like we have a couple of points where that's the case. We need to include all of them, right? Looks like we've got this point, and this point. So what are the x values here? Looks like -3, 1, and 3. So now that we know where f of x is equal to 0, let's think about for what x is f of x greater than 0. So before we were looking at where is the function exactly equal to 0? Where are the output values exactly equal to 0? Now we're looking for where are the outputs greater than 0. Thinking about this kind of in words, how can we describe the part of the coordinate plane where y is greater than 0? Well, if y is 0 right in the center, and y is negative down here and positive up here, that means the top half of the graph is where our y values are going to be greater than 0, right? That's where we have all of our positive y values, so all the stuff up here. So where is f of x going to be greater than 0? It's going to be greater than 0 anywhere in the top half of the graph, right? Anywhere above y equals 0. So where is this the case? Similarly to what we did in the last lesson, increasing and decreasing graphs, let's do some highlighting of where we're looking at before we try identifying it with interval notation. So where is this function above the x-axis? Looks like right here and right here. So we have these two parts. And again, like we talked about last lesson, we want to describe parts of a function using the x values, right? If we try to describe a graph using the y values, it's possible that multiple places on the graph have that y value. There's only one point for any given x value, right? That's our definition of a function. So we want to describe where we're talking about on the graph using the x values. So let's write the interval of x values that correspond to these pieces. So it looks like it starts at the x value -3 and continues all the way to 1. So that is our first chunk. Am I going to use parentheses or brackets? Well, Let's think about it. So at this point, what is the output of the graph? What is f of x at x equals -3? It's 0, right? The y value is 0. That's what we set up here. That's why it's the point on the x-axis. Is that output value greater than 0? No, it's not, right? 0 is not greater than 0. If we were asking where is f of x greater than or equal to 0, we would include it, but here we're not going to include it. And same thing with 1. All right, we have a second chunk, so we want to do a union. Our second chunk starts at the x value 3. Again, not included for the same reason. And continuing all the way to 4, am I going to use a parenthesis or a bracket? Well, let's do the same thing we did before. Let's check out the output value for x equals 4. We don't know what it is, but we just need to check if it's greater than 0. Is this y value greater than 0? Totally. So we definitely want to include 4, and we do that with a bracket. What if we ask the same question, but we were talking about when f of x is greater than or equal to 0? How does this change? How is our interval going to look different? So what's changed in what we're asking? Now we're asking, where are we above y equals 0 or also equal to y equals 0? So now we look back at these endpoints. Now we look back at these sections, right? This whole part is still the same. We definitely will have the same numbers in here. But let's look at these endpoints. So now, again, we said the output value at x equals -3 was 0. And before we didn't want to include that, but now we are including when the output is equal to 0. So this time we will include -3. Similarly for 1, the output is 0, so that guy's included in as well. And same thing for +3. And what about 4? Does changing whether we're greater than or equal to 0 change anything here? It doesn't, right? This is still larger than 0, so it still is included. What about f of x being less than 0? Now where are we looking? We're looking below the x-axis, right? We want to describe this part of the function and this part of the function. So this guy's got an arrow, so we know we're going off to -infinity. That always has a parenthesis. And we're moving all the way up to, where does it stop? We're going to pass through the x-axis at -3, so that's where we need to stop. Are we going to include or exclude -3? Well, again, let's think it through. What is our output value at -3? At this point, we're very well acquainted with the fact that it's 0. Is 0 less than 0? It's not, right? 0 is not less than 0, so we do not include -3. We have this second chunk, so we need to use the union symbol. That second chunk starts at 1. Again, it has an output of 0, so we do not include it, and continues all the way to +3, and +3 is also excluded. How does that change if we change the question to asking for this? So we're definitely still looking for what's underneath, but this time we're looking at what's underneath and also including what's intersecting the x-axis. So we want to again start at -infinity, and we continue all the way to -3. This time, when we're considering whether or not we include -3, remember our output is 0, and we're looking for where our output is less than or equal to 0. So because it's equal, we include it. And the same goes for the points 1 and 3. Awesome. All right, let's try another one. Okay, so we've seen this guy a bunch before. This is a rational function. Hopefully we're getting familiar with the different types of functions. So for what x values is f of x greater than 0 here? Well, again, greater than 0 means we're looking above the x-axis, right? We're looking above the line y equals 0. So definitely don't want to include this part of the function. This is all below. We need this guy to be something, so let's make it 5. I'm going to make this 5. We want to include this part of the function. This is what's greater than 0, right? This is what's above the x-axis. What are the x values for this part of the function? Well, again, we have one of these funky lines, which we will talk about tomorrow, but we are getting really, really close to 5, but not including 5. So that means we start at 5, but we don't include it. And we are continuing to, well, we've got an arrow, so positive infinity. Where is f of x less than 0? I'm going to pretend I wrote this over here. F of x is less than 0 when we are where? In the coordinate plane. Below the x-axis, right? So when are we below the x-axis? For this chunk, right? This portion right here. So how do we name that using interval notation? Clearly we're negative on this side, so starting at negative infinity and continuing all the way to, but not including, this line, which is x equals 5. So continuing, but not including 5. All right, what changes if we look at when f of x is greater than or equal to 0? Well, we're looking for when we're larger than or intersecting the x-axis. So we just need to think about where are we equal to 0, right? It's going to be the same as this, but including the parts where we're equal to 0, where our output is equal to 0. Does that happen? Does our function ever equal 0? Remember, with these types of functions, we're getting really, really close, but not touching these lines, right? So we're never going to equal 0. So because of that, our interval is the same as before. Does anything change if we are looking at less than or equal to 0? Nope. Same deal, right? We are getting really, really close to the x-axis, but we're not touching. So nothing changes from this less than 0. All right. Let's say we're looking at something like this. So here, where is f of x greater than 0? Well, again, that's asking where are we passing, where are we above the x-axis? This portion and that portion. Okay, so how do we write this in interval notation? Well, looks like, again, we're collecting x values, so all of the x values associated with this piece are negative infinity to 0, right? Not including 0 because, remember, we're looking for strictly above, right? The output value at 0 here is 0, so we don't want to include that. And then for this second piece, we're passing through at the point 4. The output value at 4 is 0, so we don't want to include that because 0 is not greater than 0. And then we are continuing to positive infinity. What changes when I look at f of x greater than or equal to 0? Well, we're still greater than 0 for negative infinity up until 0. Then when we get to 0, what happens? Let's check the output value. Remember, f of 0 is 0 here. So 0 is greater than or equal to 0, so we can include it this time. So we use a bracket. Similarly with 4, f of 4 is 0, so we do want to include 4. So we use a bracket there as well, all the way to infinity, which we always use a parenthesis with. Okay, what about f of x less than 0? F of x is less than 0, right, beneath the x-axis. So that is this portion of the graph. How can we write that in interval notation? Well, our first x value is 0, and we continue all the way till the x value of 4. Are we including or excluding those endpoints? Well, right, output value of 0 for both of them. 0 is not less than 0, so we want to exclude them. If we're looking at f of x is less than or equal to 0, again, we check these output values. They're 0. 0 is less than or equal to 0, so we can use brackets here. Awesome. So let's switch up this question a little bit. What if we were asking, where is f of x equal to, when is f of x equal to 3? Again, this is a refresher from interpreting graphs. Well, we can figure that out by checking along the line y equals 3 and seeing where we line up. Looks like we've got a point here and a point here. And the x values for those points are -2 and +5. All right, so where is f of x greater than 3? So remember before, when we were looking for where we're greater than 0, we were looking for where we were above the x-axis, right? Above the line y equals 0. Now that we're looking for where we're greater than 3, now we're looking for where the graph is above the dotted line being y equals 3. Okay, so now our highlighting doesn't really match as well. Where is the graph above the dotted line? Well, looks like this piece and this piece. So I'll make this pink so that we know that that's what we're looking at. Where is f of x greater than 3? Well, let's check it out. So we said this piece looks like this piece extends forever in that direction. So we start off at negative infinity and we continue all the way to this point. Do we include this point? Let's check it out. What is the output value there? Well, f of negative 2 is positive 3. Is 3 greater than 3? It is not. So we don't include negative 2. We have a second chunk, so we're going to use a union sign. Our next chunk starts at 5. We need to check whether we are including or excluding that 5. Again, the output value at 5 is 3. 3 is not greater than 3, so we do not include 5. And we continue all the way to infinity. Great. What happens when I ask for less than 3? Well, we're less than 3 when we are below the dotted line, right? So all of the points underneath this line y equals 3. How do we describe that area? We always use x values. Looks like it starts at negative 2. Do we include negative 2? No, right? 3 is not less than 3. And we continue all the way to x equals 5. Not included. When is f of x greater than or equal to 3? So what's going to change here? Well, we definitely still are looking kind of at these pink parts. We're starting at negative infinity and continuing all the way to negative 2. Now we check out this endpoint. Are we going to include or exclude? Well, again, our output here is positive 3. 3 is greater than or equal to 3. So we do include negative 2 here. Moving to this side, we've got this endpoint here. This piece of the function starts at 5. Is 5 included? Output value is 3. 3 is equal to 3, so yes. Similarly, for f of x is less than or equal to 3, we are starting at negative 2. Do we include it? Let's check the endpoint. Output is 3. 3 is equal to 3, so we do include it. We continue all the way to the end of this portion, which is at 5. Do we include the endpoint? Yes. This is from the section Obtaining Information from a Function's Graph. This is question 1. So we're looking at this graph. It's asking us to determine which values of x for which f of x is less than or equal to 3. This is the function that's listed in the lab manual. I just didn't use the exact picture that they used because I wanted to make the axis look better. So we're looking for where is f of x less than or equal to 3. So let's go ahead and draw our line at y equals 3. We draw the line there. Since we're looking for less than or equal to 3, it means we are looking for where we are below or right on top of that line. So definitely easy part for the first chunk, right? We've got that big dip that we need to account for. So what are the x values included there? So we definitely are starting at negative 3. Do we include or exclude? Well, looks like we're running into that line. We're right on top of it, so we are equal to 3. The output value there is positive 3, so we do include negative 3. And we are continuing along that dip all the way until we get to, looks like maybe 2.5. Do we include or exclude? Definitely going to include that one, right? Because again, the output value for the function there is positive 3, so we want to include it. Is that it? Are we done? You might think so. This is kind of an interesting question. This is the first one we've seen like this. Do you notice how the end of the function, we definitely go above the line y equals 3, but at the very end, we touch 3 again, just at one single point. We also need to include that guy. How are we going to do that? Well, in interval notation, in order to include one single x that's by itself, we write it in curly brackets. So that x value is 4. And we write that in curly brackets, curly braces, whatever you call them. Let's look at one more of these. This is number 2. This one is asking for x values for which g of x is greater than 5. So again, we need to draw that horizontal line. This time we're looking for greater than 5, so we're going to be looking at when we are above that line, y equals 5. We've got that small chunk sort of on the leftmost side, and then we have that inner chunk, and we need to write both of them. So let's start with the first one. Looks like that first one starts at -4. Is that one going to be included? Let's check. What is g of -4? What is the output value of g there? Looks like it's 8. Is 8 greater than 5? Sure is. So we keep going. Looks like we get all the way to, what is that, maybe -3.5? Is that one going to be included? Let's check it out. So we look at the output value at -3.5. Looks like it's 5. Is 5 greater than 5? Nope. So we don't want to include it. And then we need to name the second chunk, so we use the union symbol. Where does that second chunk start? We're moving from left to right. We start at -1. Is that guy included? Again, nope. And we continue all the way to, looks like +1. Is that guy included? He's equal to 5, so nope. All right, y'all, that was it. Hopefully this is making sense. Thanks, y'all.